Hello, everybody. Today, we're going to do some sequences. It's kind of like anything else. Once you know the terminology, it just makes it a little bit easier to understand the directions, understand what the expectation is, kind of know what's happening. So a lot of this is just definitions, but it's an important first step to being able to go through the process of solving a sequence series and stuff. So a sequence is just a set of numbers. It's written like a set, so it'll have like these little squiggly brackets around it. I know those are bad examples, but so that's the notation. I don't know that it's super important that the notation is there, but that's the way I'm going to write it. I don't know that you have to write it that way if you don't want to. So it's definitely a set of numbers, and it has a specific order or pattern. And whatever that means, it means, right? So it's kind of very, it's going to extremely vary from one sequence to the next. And then each number in your list, so each number or value is a term. And that matters. So each number is a term. So a finite sequence has a limited number of terms. Basically no dots, so like 1, 2, 3, 4. And an infinite sequence is unlimited. It can start or end with those 3 dots, or it could just be at 1. So we could have like negative infinity, then we can say, oh, we're going to go 0, 1, 2, 3, and then we're going to go to positive infinity, or you could have just the dots at the beginning or the end. Now, in order to establish a decent pattern, please note, you need at least 3 terms. Anything less than that, the pattern isn't going to be that obvious. So when you go to write your own, make sure you check. And when you're given one, make sure you don't just check the first 2. Check again later on in the sequence. So the first term is called a sub 1. And then after that, we just keep adding 1. So we could go a sub 2, a sub 3, a sub 4, but the generic formula is a sub n plus 1, and then n plus 1 is the term number. So we basically have the answers, so we have the sequence, then we have the term number. So there's kind of lots of numbers involved in this, and then we're going to, of course, try to connect those numbers. So that's the hardest part. So here's our example. We have this example, 2, 5, 8. Looks like to get from 2 to 5, we had 3. 5 to 8, we had 3. So I've checked it twice, so I'm feeling confident that the rest of this would be 17, 20, 23, 26, 29, 32. Let's see if we can answer these. So a sub 1, the first term is 2. A sub 5, 1, 2, 3, 4 is 14. We're just counting, so it's like it's place in line. A sub 8, 3 more would be 23. A sub 14, oh nice, don't have enough. 35, 38, 41. Don't forget about the old school little 3rd grade way of going through this. That's not anything to be ashamed of. Sometimes you just got to make the list and count them. There's absolutely nothing wrong with that, so don't be afraid to do that. A lot of times that's a great way to rescue yourself on these sequences. You don't have to do everything with algebra. So your domain is the set of term numbers. Oops. And the range is the actual values. So a lot of times our domain is going to be like counting numbers. 1, 2, we're just counting them. They're placed in line. I'm first in line, I'm 10th in line. Whereas the answer, the y value, the a sub n, is the actual, the value of the number or that answer in that list. And so again, we're going to use natural numbers here, also known as counting numbers. We're not going to use whole numbers or integers because we don't want to start with 0. So whole numbers starts with 0. A sub 1, unless it's very, very specific that a sub 1 is 0, but a sub 1 this is your term number. we're not going to call it a sub 0. Right? So we're not going to use that. So we're not going to start with a 0. We're going to start with a 1. We're counting them. Now we have two kinds of things that we're going to go through today, recursive and explicit. And knowing these two never go away. All right, so arithmetic, geometric, some of the things that we do kind of come and go, but these two were going to be the main ones, which is why we started with them. So a recursive formula, and we're going to go through a bunch today, is a rule, pattern, formula, whatever you want to call it, that uses one or more previous, so the terms that come before it, to generate the next term. Oops. The most famous of these sequences is the Fibonacci sequence. Maybe you've never heard of it, so maybe it's not that famous. So this is the Fibonacci sequence. 0, 1, 1, 2, 3. You see the pattern yet? In 13 seconds? Okay, well, maybe not. So basically, 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. So then we would go 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13, and so on, and forever we go. So basically, you add up the two terms before. So how would we write that? A sub n means any term. I can find a sub 4, a sub 5, a sub 20, a sub 400. I could find any place in line with this formula. And so what did we do? We took the term before it, right? So we're going to subtract 1, and we added the term before that. So if we think about a sub 1 being the first term, if we move this way, this is a sub 2, a sub 3, right? And then if we go this way, we'd have to subtract. So then that's why this is a sub n minus 1, a sub n minus 2. So this would really be a sub n plus 1, because this is, if we just sort of, and this would be a sub n plus 2. So that's how this kind of list kind of goes. Backwards we subtract, forward we add. All right. Now, some actual problems. So give the first 5 terms of each sequence. Again, I'm going to use a little set notation. The first term they tell you is 25. Then notice, they say, hey, to get to the next term, to get to the term you're looking for, that's a sub n. You're going to take the term before it and subtract 7. So this is a fancy way of saying just take that number and subtract 7. So you just have to be able to read this notation. All right, so this is what I'm talking about right here. To find the term you're looking for. What term are you looking for? I don't know. Whatever term it is. Any term. Take the number before it and subtract 7. So 25 minus 7 is 18. Minus 7 is 11. Minus 7 is 4. Minus 7 is negative 3. Any numbers are possible. You could have decimals. You could have negatives. We will probably not have a lot of radicals. I know maybe you're sad by that, but it's hard to do radicals, I think, with just arithmetic, so I've kind of stayed away from them. So let's try this one, now that we maybe have a better understanding. So our first term is negative 2. So that's definitely got to go on our list. So now we have to take 3 times negative 2 and then add the 1. Use your calculator if you don't want to do this arithmetic. This is straight up arithmetic for the rest of the school year. So negative 6 plus 1 is negative 5. Then we start all over. 3 times negative 5 plus 1, so negative 14. 3 times negative 14 plus 1, negative 41. And then 3 times negative 41, and then we'll add the 1, so this is negative 122. A recursive rule is much harder. You're welcome. This is you guessing and checking. That sounds fun. Guessing and checking until you can figure out the pattern. I know, not enjoyable. And you'll be surprised. sometimes you're going to be like, wow, how did I know that? And some people are just naturally good at this. I don't know why I can't write. So let me get myself together here. So we have 9, 9s are hard, 13, 17, 21, 25. All right. And then we're trying to tie this into the term number 1, 2, 3, 4, 5, and so on. So the pattern means I have to go from 1 to 9, from 2 to 13, from 3 to 17. Oh, wait, this is recursive. I'm doing explicit, which is harder. Okay, so recursive is, I was thinking this, and I'm ahead of myself. Pays to read the direction. So this isn't that bad. So we know that a sub 1 equals 9. And then how do we go from 9 to 13? Ignore this. How do we go from 9 to 13, from 13 to 17, 17 to 21? This looks like we added 4, add 4, add 4. So then a sub n is going to equal the term before it, a sub n minus 1 plus 4. Okay. Now to find a sub 8. Up to you. Are you just going to, because 8 isn't that far away. We already have 1, 2, 3, we already have 5. Are you just going to keep adding 4? So 29, 33, 37. That's probably the easiest way to do it because we don't really have a rule. We need the 33 in order to get to the 37. So a sub 8 is 37. So again, don't forget about moving forward. We're just going to fill in and just keep, following the pattern. A recursive rule requires 2 things. It requires that you state the first term, and then how do you move on from there? So my thoughts are finally catching up to myself here. So explicit formula is what I was trying to do, sorry. This is a rule that connects the nth term as a function of n. Huh? What does that mean? So we're going to connect the term number to the term value. If you remember those definitions from the front. I'm really struggling. Connect term number, so it's place in line, to the answer. An explicit formula requires just one formula. So we're going to do this the easy way first, and then we're going to go backwards. So here they give us the pattern. So we know that the numbers we're plugging in are the counting numbers. 1, 2, 3, right? So these are our values of n. So if you plug a 1 into this formula, we get 5 plus 1, so we get 6. Then plug a 2 in there, we get 11. Then plug a 3 in there, we get 16. So for number 5, if n equals 1, we would have 0 over 3. So our first term is 0. If n equals 2, we'd have 1 over 4. And if n equals 3, we'd have 3 minus 1, which is 2, over 3 plus 2, which is 5. And so this would be 2/5. Okay, ready? We're going backwards now. That was not very long to get used to it. Now, you're going to try to connect the 1 to the term number, the 4 to the term number, the 9 to the term number, the 16 to the term number, the 25 to the term number. You see it? And then we're going to find a sub 25. So what's going to happen is they're going to start to make this number much larger so that you can't just use, well, you could, but it's going to be super annoying to use like the elementary school rule of just sort of, I'm just going to write out the first 400 terms to find that 400th term. So that's what's going to change as we move forward. They're going to ask you to find some ridiculous number way down the line just to prevent you from just doing it that way and sort of force you to do the algebra. But you don't have to do it that way. If you want to just write it all out, just write it all out. So I don't know, I'm trying to stall to see if did you figure that out yet? So if we have this 1, good 1, 2 to 2, this looks like 1 squared, 2 squared, 3 squared, 4 squared. So I'm going to say that that's probably right after checking it over and over, that your nth term is your term number squared, which means a sub 25 is just 25 squared, which is 625. I wanted to start with a nice easy one. This is not so easy. 1, 2, 3, 4, 5. Ugh. Well, if you think, well, I'm just going to multiply, it looks like I'm going to multiply by, I don't even know. If we multiply by 3, 1 times 3 is 3 plus 6. So if I take 2 times 3, that's 6 plus 6, that's 12. Ooh. 3 times 3 is 9 plus, I'm off. So that doesn't work. I was checking 3n plus 6 based on my first term. Sometimes the first term is harder. I'm going to try with the second term. I don't know why, but I feel like I might be better off with that second term. I know we're adding 2 from term to term, but we didn't start at 9, so we can't just say add 2. Add 2 is recursive. Recursive is go from term to term. We want explicit, which means I can find any term number. It doesn't rely on any of the terms before it. Let's try multiplying by 2. So 2 times 2 is 4. To get to 11, I'd have to add 7. So now I'm going to try 2n plus 7. I felt like this 3n plus 6 was really close. It was wrong, but it was close. So then let's try with a 4. I'm just randomly picking one. 2 times 4 is 8 plus 7. Ooh, 15. Ooh. Let's try the first term. 2 times 1 plus 7 is 9. Boom, there it is. And just like that, a sub n is 2n plus 7. A sub 25 would then be, of course, 2 times 25 plus 7, 57. Now we're going to do both. This explicit rule, it gets easier, I promise. It's hard the first couple days. It'll be easier as we go. I absolutely promise you that. So don't get frustrated. Don't quit. Don't be like, I'm not doing this. Just guess and check. If you can't figure them all out, so what? Just keep guessing and checking. You'll get some of them. You might not get all of them, and that's okay. All right, so I'm going to do the explicit first because I don't know why. So I'm going to do the explicit and recursive. Recursive would be, okay, say your first term, and then say how you get from term to term. The problem with doing it is that you're going to be just like, oh, well, you just add 3, because explicit may or may not have a 3 in it. So that's going to be a little bit frustrating, but I would start with that. So like, for example, I know I'm sort of skipping around. This one up here, I'm way up here. Hello, I'm up here. This one, it seemed like we added 2, we add 2, we add 2, and then there was a 2 in the formula. That's not a bad place to start. I'm not saying it's going to be right all the time, but it's a good first guess. So then to find the recursive, we're going to do a sub n. That's how you do this. And it's the term before it, a sub n minus 1, and we add 3. So adding 3, I'm going to try multiplying by 3. And I like to just, I hate the first term, but I'll start there. So 3 times 1. How can I get from 3 to 4? Well, I'll add 1. So let's try that again with the 2. So 3 times 2 is 6. Oh, plus 1. We just did that. How did that happen? A sub n is equal to 3n plus 1. Okay. See? It's already easier. I'm just kidding. All right, so I'm going to do the recursive first, because it does seem like that recursive helps us get the explicit. So the recursive is a sub 1 equals 1/2. Everybody can do that part, at least get that far, and then you say a sub n equals. Well, let's figure out How do we get from term to term? Oh, add 1/2. If you want to do it in decimals, you can. 0.5, 1, 1.5, 2, 2.5. That's easier for you. So a sub n is to take the term before it and add 1/2. All right, let me get rid of these. Because now we got to connect this to the term number. How do you go from 1 to 1/2? How do you go from 2 to 1? How do you go from 3 to 3/2? How do you go from 4 to 2? How do you go to 5 to 5? Anybody see it? You feel it? You got it? I thought if I said it over and over again, it would help you. So it looks like to me, we just divide by 2, right? You take your term number, divide by 2. Term number is 2, divide by 2. That gives us 1. Term number is 3, divide by 2, you get 3/2. So the explicit is a sub n is equal to the term number divided by 2. Just give yourself a chance to sort of get used to this. And then we have these little application problems. So Rachel's friend's pushing her swing. Another friend measured her path. How convenient. On the first swing, she traveled 32 feet. I don't like to read, so I'm going to write these down. 32. Second, she went 16, then 8, then 4, and then 2. On and on. So we're trying to write the recursive and the explicit rules. So we have learned that recursive helps us write explicit. So recursive is a sub 1 is equal to 32. And honestly, we just divide by 2, right? So how would we write this? A sub n is equal to, well, it's up to you how you want to write this. I want to write this as a sub n minus 1 over 2. Or you could write this as 1/2 times the term before it. Or you could write it as 0.5 times the term before. But remember, you got to use a sub n minus 1. So there's your recursive. Explicit. It's a little harder. This is a 1, 2, 3, 4, 5. Our term numbers are going up and our answers are going down. Well, we use the 1/2 in the recursive. This is no joke right here. So we got to use one. Probably have to use the 1/2 in the explicit. So that might help us. Let's think about what's 1/2 to the first power is 1/2. 1/2 squared is 1/4. 1/2 to the third is 1/8. Anybody got it yet? So if we take 32, let's do some little calculations down here. 32 to get to 16, we'd multiply by 1/2. Well, here's my term number. Where's my n? N is 1. 32 to get to 8. I don't know why I feel like I need that 32. 32 times 1/4. 32 times 1/8. This is 16. This is 8. This is, ooh, I might be onto something. All right, so 1/2 n minus 1. Because, so my first term is 32. I don't know why I felt like I needed to use that. It just felt like I did. It was just a guess, really. Yeah, and that's a bad answer. I don't really have a good mathematical answer for that. So from there, I just was like, okay, I made my list of 1/2, as you can see. So then this is 1/2. My second term needed to multiply by 1/2. My third term need to be 1/4. So I needed a 2. My fourth term needed the power of 3. So 4 minus 1. So that's how I knew that I had to subtract 1 in my power. There's probably other answers for this, but because this is the one in my head, I can't come up with another answer. So if you have another answer that works, you could be correct. So it's not like there's only one correct answer for these. That was just the one that I came up with.